Hello there, and I'm going to teach you about modular arithmetic. What is modular arithmetic? Well, think of a clock. On the clock's face there's 12 numbers, one going straight to 12. But you know there's 24 hours in a day. So how can that be, if there's 24 hours in a day, but how can it be captured on a clock that's got 12 numbers? This is where modular arithmetic comes into it. For example, 13 o'clock, it wouldn't be 13 on the clock, the face of the clock, because there's only 12 numbers. So what would that become? It would become 1 o'clock, because I'll show you why. 13, see as 13 divided by 12. How many 12s go into 13? 1. And what's the remainder? 1. So again, it would be, if I wanted to, let's say 8 hours ahead from now, no, let's say 14 hours ahead from now, it's 4 o'clock, 16, 14 hours ahead, that would be, you would think it's 30, so it'd be 30 hours, we'd be in the 30th hour, from the 16th hour to the 30th hour. But again, 30 hours can't be captured on a face that's 1 to 12. So you do 30 divided by 12, which is 2, remainder 6. Therefore, 14 hours ahead from now, it'll be 6 o'clock in the morning. So in modular arithmetic, so that will be clock, that's clock arithmetic. 13 o'clock, 14 o'clock, 16 o'clock, that's 1 o'clock, 2 o'clock, 4 o'clock. That's where clock arithmetic and modular arithmetic comes into it. So modular arithmetic is finding the remainder. It's written in the form of A mod B equals R, with A being the dividend, the number that's being divided into, B being the divisor, the one that's doing the dividing, and R being the remainder, what is left over after A has been divided by B. So let's look at the first question. What is 37 mod 10? Let's write out this question. 37 mod 10. So just looking at our rule, A's being the dividend, A being 37, B's being the divisor, 10. R is what we're trying to find, the remainder. So basically we're trying to figure out what's the remainder from when you divide 10 into 3.5. There's no decimals when it comes to finding remainder. Otherwise we could just easily do 37 divided by 10, 43.7. That's not what we're looking for. We're trying to find out the remainder when you need to find the highest multiple that goes in, highest multiple of 10 that goes into 37. So that would be 30, right? 10 multiplied by 3. So you do 37 multiplied by 10. No, 37 minus 10 multiplied by 3. That's because you're trying to find out the remainder. Because 30 is the highest multiple that goes into 37. Wouldn't be 40, because 40 is greater than 37. We're trying to find out the remainder of when we put a certain, how many 10s can we, what's the remainder from when we divide multiples of 10 into 37. So 37 minus 30 is equal to 7. 10 can't go into 37 because 10 is greater. Therefore, 7 is your remainder. Therefore, the answer is 30 to 37 mod 10 is equal to 7. Let's move on to the next question. Find the remainder of 27 mod 6. So let's write out the question. 27 mod 6. Same process as the first question. 27 is the dividend, the number that's being divided into. B is the divisor. How many multiples of 6 can go into 27? And what will be left over after you put that amount of 6's into 27? So this is again, I mentioned it's good to know your multiples, because questions like these you can answer in a jiffy. But if you're not good at your multiples, you're not going to know how many 6's go into 27. You're going to be using your fingers. You're going to be doing, by then, if you're in an exam solving a question like this, you're wasting time. You can see, if you know your 6 times tables, you know 24 goes into 27. 4 multiples of 6 go into 27. So we do 27 minus 6 multiplied by 4. So 4 multiples of 6. So that's 27 minus 24. That is equal to 3. Therefore, 3, with 3 being a remainder, that's the remainder. 6 can't go into 3 anymore. So therefore, because 6 is greater than 3. See now, let's say if the answer was 8. Let's say the remainder was 8. That answer would be wrong, because 6 can go into 8. You'd have to keep going one more time, and then the remainder would be 2 from that 8. But obviously the question will be written differently. So for example, if you added 8 on top of here, 35 mod 6, remainder would be 5, because 5 lots of 6 go into 35, which is being 30. But I digress. Let's just go back to this question. So 27 mod 6 is equal to 3, with 3 being the remainder of 27 mod 6. Let's move on to a much harder question. Use the modular arithmetic method to find when 131 multiplied by 263 is divided by 13. So you might be looking at the question thinking it's daunting. It's basically, it's the same question as the others, except for you just need to do an extra step. You need to work out what 131 multiplied by 263. So you use your calculator, 131 multiplied by 263. So here, 100, let's write out the question. It's always good to write out the question. So we're going to write out 131 multiplied by 263 mod 13, because 13 is the divisor, and the multiple of 131, the multiplication that you get, the answer you get from when multiplying 131 by 263 is what you're going to be trying to find out. How many 13s go into that number, and what is the remainder after putting a stat amount of 13s into that number. So 131 multiplied by 263 is 34,453. So you'd write the question like exactly like the previous question, 34,453 mod 13. Okay. This is important again to know your 13 times tables. So you don't know your times tables now. I know that's a big number. How are you going to figure out what's the remainder from when you divide, you put the highest multiple of 13s into 34,453. What are you going to get from that when you divide? What's the remainder? So you want to do, this is where you might be familiar with the method chunking. So, if you don't know your multiples of 13, you could do, if you only know maybe from 13 to 26, or a 39, and that's it, that's fine. Go with the multiple so that you know. So basically, you want to do chunking, you want to eliminate it till you find the remainder. So 26,000 goes into 34,453. 39,000 can't go into that because 39,000 is greater than 34,453. So we're going to have to do chunking by doing 34,453 minus 13 multiplied by 2,000. So now we're going to work out 553 minus 26,000. Space this out. That is going to be 8,453. Just start with, if you're not sure how I work that out, you can just use a calculator if you want. I just did mental maths in my head. If you need to use a calculator, go ahead and do so. Minus 26. Yes, 8,453. Gonna keep going, we're not done yet. 13 goes in, how many 13s go into 8,453? So we're still going to continue our chunking process. You can start off small, keep doing it small, doing with multiples that you know. So we're going to do 13 multiplied by 5, which is 65. We're going to use that multiple, so we're going to do 8,453 minus 13 multiplied by 500, which will give us 6,500. 8453 minus 6,500. We will get 1,953. So again, we're still continuing the chunking process. We're still trying to find out what the original question, 34,453 mod 13, what's the remainder from that? So let's continue our chunking process. Again, we can do 1,953 minus 13 multiplied by 100. So that'll be 1,953 minus 1,300, which will get 653. 653 minus 13 times by 50, which will be 653 minus 650, and the answer is 3. 13 can't go into 3 anymore. Therefore, your answer to 131 multiplied by 263 mod 13, which is the same as writing 34,453 mod 13 is equal to 3. And that's how you work out that question. 3 being the remainder of 34,453 mod 13. When you divide 34,453 by 13, you'll get a remainder of 3. Let's move on to the final question. Same process that we did with the previous question. We're going to work out what 456 multiplied by 1,808. And we're going to work out mod 9. So we're going to work out the remainder of that. When you find out what's the answer to 556 multiplied by 1808 and divide that by 9? What's going to be remainder from that? That's what we're trying to find. So let's key into our calculator. 456 multiplied by 1808. 4, 5, 6, 1, 8, 1808. So that is 824,448. So we're going to work out the modulus of modulo 9. We're going to work out the remainder to that. How many 9s go into 824,448, and what's the remainder when you divide that by 9? So again, same process with the previous question. We're going to do chunking in multiples of 9 to find out a remainder. So if you know your 9 times tables, so 824,448 minus, we can do 810,000, because 81 is a multiple of 9. Did properly. 9 multiplied by 90,000. What's that equal to? So 824,448 minus 810,000. And your answer will be, so 824,448 minus 810,000 will be equal to 14,000. Sorry, yeah, 14,448. Apologies for that. Had a Freudian slip. And we can just use the calculator to double check. I know I have a calculator to use, but I like to train my brain to try and work out in my head. So that's correct. We're going to continue our chunking process. So we got 14,448. We can subtract 9,000 from that. So 9 multiplied by 1,000. 14,458. 48. Oh. Nomlock likes to have a mind of its own. Minus 9,000. So that is equal to 14,448 minus 9,000 is equal to 5,448. We can subtract 5,400 from that, because 54, that's a 54 the multiple of 9, and we would just multiply that by an extra 100 of what we would multiply 9 to get to 54. So 9 times 6 is 54. To get 5,400, add 2 extra zeros, so it would be 9 multiplied by 600. So 5,448 minus 5,400 is equal to 48. How many 9s can go into 48? Only 5. So we do, because 9 multiplied by 5 is 45. So 9 multiplied by 5. So 48 minus 45 is equal to 3. Therefore 3 is your remainder, because 9 can't go into 3 anymore. So Your answer, so when you multiply the remainder from when you multiply 456 by 1808, and then you divide that by 9, the remainder from that is equal to 3. So 3 is the remainder, and that is how you use modular arithmetic to work out the remainder. Thank you for listening, and goodbye.